we're going to take a break from add, subtract, multiply, and divide and look at the properties of positive and negative numbers. Now, these are kind of the rules of the game. These are the assumptions that we make about numbers. The important ones: associative property, commutative property, and distributive property. Here's a problem. Apply the associative properties, and I've got 3 problems written down here. So first of all, the associative property is what allows us to regroup when we have numbers that are connected with addition or with multiplication. So since this is all addition, the x and the 2 are grouped together, I can change that with the associative property and know that I haven't changed the value of this expression. Now, I do that because now I can add 2 and 7. See, I can't add 2 and x because I don't know what x is, but I can add 2 and 7. So that simplifies this expression down to just x plus 9. So that's one way in which we use these properties, is to simplify expressions. So anytime I want to change the grouping when it's all addition, I can do that. Here's our next problem. 9 times 6y, okay. In parentheses is 6 and y, so what I want to do is change the grouping to 9 times 6 and all that times y. So the associative property changes the grouping. 9 times 6 is 54 times y. So the reason why 9 times the quantity 6y comes out to be 54y is because of the associative property of multiplication. Here's another problem. How about 1/3 times 3x? Well, this is also going to be the associative property. Instead of grouping the 3 and the x together, and this is multiplication between 3 and x. They're not connected together. It's multiplication. So I'm going to change, and this is multiplication, so I'm going to change the grouping from 3 and x to 1/3 and 3. And write this as 1/3 times 3 times x. Now, 1/3 times 3 is 1 times x is simply x. So that's another property of numbers that says that 1 times any number is the number itself. So how do I know that 1/3 of 3x is just x? I know because I can apply the associative property this way and group the 1/3 and the 3 together with the x outside. 1/3 times 3 is 1, 1 times x is x. The next few problems we want to work involve the distributive property. Let's apply the distributive property. The distributive property works with multiplication and addition and subtraction. So multiplication distributes over addition or subtraction. So I multiply 8 times x, and I get 8x. Subtract, that's that subtraction sign, 8 times 2, which is 16. So 8x minus 16 is the result of distributing this 8 over this difference, x minus 2. Here's our next problem. 2 times the quantity 3a plus 7. I want to apply the distributive property. So I have 2 times 3a plus 2 times 7. Now, I can actually multiply here. 2 times 3a by the associative property is 6a. I won't show all those steps, but it does come out 6a. Plus 2 times 7 is 14. So you can see that these properties are important. I want to be able to change this expression right here, 2 times the quantity 3a plus 7, into equivalent expressions that might be easier to work with. And as it turns out, when we solve equations, this expression right here is actually easier to work with because it doesn't have these parentheses. But I have to make sure I get this correct. It would be incorrect to write the answer to this as 6a plus 7. You would have forgotten to multiply that 7 by that 2. So I want to practice applying that distributive property. Here's another one. 7 times the quantity 2x plus 4, close the parentheses, plus 10. Now this 7 distributes over this sum, so it'll be 7 times this term and this term, but not times this. 7 times 2x plus 7 times 4 plus 10. So notice I just do the distributive property over those two terms. 7 times 2x by the associative property is 14x. 7 times 4 is 28 plus 10. And now 28 and 10, I can add those two together. I get 14x plus 28 plus 10 is 38. So kind of a complicated expression, and it simplifies down to 14x plus 38. I could check this by substituting any number I want for x in here and simplifying this expression. If I substitute the same number for x in down here and simplify this expression, what I get simplified here is exactly the same as what I get simplified here. So this expression is in fact equivalent to this expression, but this one's going to be a little easier for us to work with.